proofs. So properties are going to help us deal with proofs. So we're still working on the same thing. If you see this, this says given parallel lines that are transversal, you should be able to prove theorems such as alternate interior angles are congruent, vertical angles are congruent, and consecutive interior angles are supplementary. So we're still working on the same thing, but we're just going to enhance that a little bit. So today's objective, you should be able to understand the following properties and know how they're used. In a proof, okay? And that would be the transitive property, the reflexive property, and the symmetric property. So when we're dealing with proofs, we use those three properties more probably than anything else. We use everything else too, just not as often. We use definitions, we use theorems, but we also use these three properties. So first of all, what does it mean to prove something? If you have an example of when you had to prove something to someone, how did you do it? So if we're having a conversation, David and I are having a conversation, and he says, you know what, give me a famous baseball player that you know. You're not a baseball fan. You don't follow baseball. Anybody here follow baseball?
David Ortiz.
All right, so Jacob, if you follow baseball, who's a famous baseball player that's a couple of years older than current?
A couple of years
older. Who's a famous baseball player that you would know?
Babe Ruth.
Not old. That's when the big game was invented.
Oh, that's all I knew.
Robinson and Bo Jackson.
Okay, so let's shh, quiet down for me, please. Shh. So let's look at one in particular. He says Bo Jackson was the best baseball player in recent times, and he's got to prove that to me, right? He's got to prove that to me. And how would you prove that to me? How would you prove that to me?
Bring up his batting average.
Okay, you would show me his stats, right? You might show me how many games he missed in a row, if he missed any games, right, due to injuries. You might bring up the fact that he was dual sports, right, at one time. So he was playing professional baseball as well as playing professional football at the same time, in the same years, right? So no time off, right, for recovery, things like that. So you might use that proof to show me that. So that's how we do it. You know, we have to support our ideas. We can't just say, no, I'm sorry, Bo Jackson was the best. And you say, no, Babe Ruth was the best. And he goes, no, Bo Jackson was the best. You go, no, Babe Ruth was the best. You're not getting anywhere, right?
That's me and Matt.
So you compare, you're going to compare batting averages, right? You might compare batting average. You might compare the fact that he was in more than one sport, things like that. But you're backing up the information you're providing with proof, with information. So in math, we use proofs to demonstrate a statement or something we've discovered is true. We use different theorems and properties to make our point. Okay? So one of those properties is called the reflexive property. Reflexive property. Now, I remember this property because I think of a mirror when I think of reflexive property, because that's really what it is. Any number or variable is equal to itself. That's all that means. So A equals A, B equals B, 75.2 equals 75.2, and you think, well, that's silly. Of course we know that. Okay, but when we start dealing with proofs and triangles, triangles may actually share a side. So you may have two triangles that are connected, and they're connected by one side. And in order to prove that those two triangles are congruent or the same size and shape, I have to say that that side is equal to itself because it's actually part of two different triangles. And the way we do that, we use the reflexive property. That side is congruent to itself. That means the side that's part of this triangle is congruent to the same side as part of this triangle. But we use this property to do that. So any number or variable is equal to itself. A equals A, 5 equals 5, 75.2 equals 75.2. Gene is equal to Gene. Gene is the same height as Gene. Okay? So I think of that as a mirror and think of the reflexive property, because when you look at a mirror, that's your reflection. So reflexive property. Then we have what we call the symmetric property. Symmetric property. Gene is the same height as Pedro, and if Gene is the same height as Pedro, then Pedro is the same height as Gene. Okay? So another way to say that would be if 5 plus 3 equals 8, then 8 equals 5 plus 3. Right? You're saying the same thing, only you're just saying it in reverse order. Symmetric property. 5 plus 3 equals 8. And 8 equals 5 plus 3. So if A equals B, then B equals A. Example in equations, if you have 35 equals 2x minus 8, then 2x minus 8 equals 35. Makes sense, right? But we call that symmetric. Okay? Symmetric. Symmetric property. So 3 properties we're going to learn today, right? Reflexive property, symmetric property, and the next one is the transitive property. All right, so the transitive property. If Gene is the same height as Pedro, and Pedro is the same height as Chris, then Gene is the same height as Chris. If Babe Ruth had the same batting average as Bo Jackson, and Bo Jackson had the same batting average as Jackie Robinson, then Babe Ruth had the same batting average as Jackie Robinson, right? If they're both equal to the same thing, then they're equal to each other, right? If they're both equal to the same thing, then they're equal to each other. That's what that means, the transitive property. So, here's an example. If 2 segments or angles are congruent to 2 congruent segments or angles, they are congruent to each other. So if angle A is congruent to angle B, these two are, so if this is 20 degrees and this is 20 degrees, right? They're equal to each other. And B is equal to C, then C is equal to A, and it's also 20 degrees. A is equal to B, and C is equal to B, then C is equal to A. Transitive property. All right, so let's look at this just a minute. We're going to see if we can name these 3 properties. So on your paper, real quick, just off to the side of each one of those, see if you can name what property they're referring to. So remember, it's the 3 properties. We're talking about the transitive property, the reflexive property, and the symmetric property. Do you have a pen? Do you have a pencil? Would you like to use it? Yeah. Are you doing okay? It seems like you're checking out in my class for some reason. Don't do that. You'll be lost. Okay, you gotta stay with us. All right, let's look at the first one. If GH is congruent, or line segment GH, I should say, if line segment GH is congruent to line segment JK, then line segment JK is congruent to line segment GH. What property is that? Symmetric. That's symmetric, right? It's symmetric. It's the same thing, only in a reverse order, right? That's what symmetric means. If GH is congruent to JK, then JK is congruent to GH. Okay. Yes?
So on the transitive.
We're not to transitive yet. So let's get to the next one, and then we'll talk about the last one, and then you can ask your question about transitive, okay?
Okay.
So the next one says that DE is equal to DE. What would that be?
Hey, reflexive.
That would be reflexive property, okay? So this would be reflexive property. It's congruent to itself. Okay? DE is congruent to itself, that's reflexive. We think of that by looking in a mirror, it's reflexive. Okay. Last one, if angle P is congruent to angle Q, and angle Q is congruent to angle R, then angle P is congruent to angle R. And that would be the transitive property. Okay, transitive property. Go ahead with your question, David.
Could there be, like, is transitive only limited to 3?
Normally, yeah. Because if you have one thing congruent to another and another one congruent to that, these two have to be congruent to each other. How do you get the 4? It's almost a triangle-based property, right? Triangle-based property, you know? So if you liked Julie, and I'm just throwing a name out there, I don't know there's nobody in here named Julie, is there? I don't think so. So if David likes Julie, right? If David likes Julie, and Julie likes Sam, does Sam like David?
Yeah.
Of course! No. Okay, no, that's not my question though. Like, say, okay, P is equal to Q,
Yeah.
Q is equal to R,
Yeah.
P is equal to R. So say there was like R equals to D. Would D equal to P? Like,
Yeah.
would that still be?
Yeah.
but would
You're
that
just-
be transitive?
No.
Is there like
No,
a
that
thing
would-
called
that would be-
quantitative?
No,
Or-
no, that wouldn't be. That wouldn't be. It has a different property to it, but it wouldn't be that. It's more substitution property. We would call that substitution property because what you would be doing is you're substituting the value of one into the value of the other. So you use more substitution. The transitive would just be the through.
If you make it squares.
Okay. Good question though.
I was so confused during the
All right.
girl.
Sorry. All right, let's go over the assignment we're going to be working on today. You leave that on for a while. There we go. All right, so let's start off with these first questions here. So this is kind of that proof that David was talking about. This would be the transitive property, right? This is going to be that transitive property. So how would you prove that angle 4 and angle 6 are going to be equal to 180 degrees? How would you prove that? Now, what I like to do don't do that ever in my class. Don't get up. Don't walk over there and throw something away. Try not to poke holes in your paper, okay? During my class. Don't. Okay, so we're talking about how would you prove that angle 4 and angle 6 are going to sum to be 180 degrees. A lot of times just assigning a value to them will help you determine the right answer. Okay, assigning a value. So let's look at angle 4 and angle 6, okay? Because that's what we're trying to prove is going to sum to 180 degrees, okay? So let's say that angle 4 was 60 degrees and angle 6 is 120 degrees, okay? So we're trying to prove that, okay? We're trying to prove that. So we know that our first response is we got to determine, because it's given us part of the answer, there's two angles there that it's going to help us do that are corresponding angles, okay? Corresponding angles. But at the same time, we got to take into consideration the second part of that, because the second part of that is going to be a linear pair. So we got to look at angle 6 and say, all right, where is that a linear pair? Where is that a linear pair? Because 4 and 6 are going to sum to be 180 degrees. And we could do it the other direction. We could do it with angle 2, okay? But we want to look at angle 6, or excuse me, angle 4, we want to look at angle 6 and see where that linear pair is. Well, there's a couple of linear pairs here, right? There's a couple linear pairs to angle 6. We have 5 and 6 that would be a linear pair, right? And we have 6 and 8 that's going to be a linear pair. Okay. Everybody see that? 5 and 6 is a linear pair, 6 and 8 is a linear pair. But we have to take into consideration angle 4 and corresponding angles, or angle 6 and corresponding angles. So if you look at angle 4 and angle 8, what kind of angles are those?
Corresponding.
Anthony?
Corresponding.
They're corresponding angles, okay? So that's kind of take care of that first part. Let's look at the second part. Are angles 8 and 6 a linear pair?
Yeah.
Yeah. So let's see what happens. So angle 4 and angle 6, excuse me, 8, sorry. Angle 4 and 8 are corresponding angles. What do we know about corresponding angles? If we have parallel lines, they're going to be congruent, right?
Yes.
So if angle 4 is 60, what would 8 be?
60.
So let's just write 60 down there.
Oh yeah, I mean, that tells us it's kind of like it's parallel. You don't have the two arrows. Well, we don't have the big arrow.
Parallel lines and transversals with proofs. So they're basically telling you in the instructions that these are parallel.
Oh, it's a real question.
Yeah. All right. So 4 and 8 are corresponding. And if 4 and 8 are corresponding, then they're the same measurement. So let's just make that 60. Okay. Now, do we have a linear pair that's going to be 6 and 8? Yeah. So 6 and 8 are a linear pair. So we could make that. Now, the reason I say 6 and 8 is a linear pair is because a linear pair we know is supplementary, right? We know a linear pair adds up to being 180 degrees. What we don't know is we don't really know that 4 and 6 are supplementary yet. We don't know that 4 and 6 is supplementary. But if 4 and 8 are equal, right? If 4 and 8 are equal and 6 and 8 are supplementary, transitive property, right? We're going to write it a little different, so think about it in your head. So if 4 and 8 are equal, 4 and 8 are equal, and 6 and 8 are supplementary, then 6 and 4 have to be supplementary because these two are equal. That would be the transitive property, right? So if these two are equal and these two are supplementary, then these two have to be supplementary.
So there could be different signs.
Different signs.
Like, I thought we only could do like 8 and 4 are equal, so 4 and 1 are equal, and 1.
Okay, so it's the same kind of thing. 4 and 8 are equal,
Yeah.
right? So we know those are equal. 6 and 8 are supplementary. So if 6 and 8 are supplementary and 8 and 6 have the same measurement, then 4 and 6 have to be supplementary.
All right.
Transitive or substitution, right?
All right.
Substitution property. I can substitute the value of 4 in place of 8 and have the same measurement. So I know those two are supplementary. Okay? Let's look at this one. How would angle 3 and 8 sum to 180 degrees? So we have 3 and we have 8. Okay? We have 3 and we have 8. So we've got to figure out some way to find a linear pair, and then the other ones are going to be alternate interior angles. Okay? So first of all, the only one of those two angles that are interior, alternate interior angles, is 3, right? So if we're going to find an alternate interior angle to 3, it has to be 6. Okay? Has to be 6. So we can actually fill this out first. An alternate interior angles, 3 and 6. I know I have to deal with angle 8, right? This is a linear pair here, right? This is a linear pair here. I know I have to deal with 6 and 3. So 6 and 8 is a linear pair. So 6 and 8 is a linear pair. And if these two are supplementary, right? If these two are supplementary, so let's make them supplementary. So let's make this 40 and make this 140, just because. So if we make this 40 and this 140, so if these two are a linear pair, they're supplementary, and these two are congruent because they're alternate interior angles, let's make this 3 congruent to that 40. So this would be 40. So if these two are supplementary and these two are congruent, then angle 3 has to be supplementary to angle 8. Is that true?
Yeah.
It did wind up true, didn't it?
It's crazy.
So if these two are congruent and these two are a linear pair, then these two have to also be supplementary. Have to add up to be 180. Does that make sense? If it doesn't, just ask. You're kind of just playing it by ear. We're just learning the proofs, right? We're just getting our feet wet. What do we know about vertical angles?
They share a vertex.
And?
They're congruent.
They don't share any sides.
So, a little louder.
They don't share any sides.
Yeah, so vertex or vertical angles, they have a common vertex and they have no common sides. Okay? No common side. So technically, B and D would be vertical angles and A and C would be vertical angles, right? And yesterday I said you needed to know one thing about vertical angles. What was that one thing? So all you have to remember is one thing about vertical angles. I said it probably 5 times yesterday.
They're the same measurement.
Which means they are, in geometry terms, we call that being congruent, okay? And I said you need to know one thing about vertical angles, and that is that they are congruent. And they are congruent how often?
Always.
Always.
the time.
They're congruent always, okay?
Crazy.
So now what we're trying to do is we're trying to prove, now what we're trying to do is we're trying to prove that, right? We're trying to prove that vertical angles are congruent. So, we want to know B and D, right? We want to know those two are vertical angles. So what two angles could you add together that would equal 180 degrees that will help us with B and D? Somebody just name me 2 angles that we could use.
A and DC. A and B.
A and B. Okay, so let's use A and B, okay? Let's use A and B first of all. So we know that A and B are what kind of pair, Tommy? What would you call that?
I have no clue.
Now do you remember?
Yep.
A linear pair, okay? So we call that a linear pair. A and B are supplementary because they are a linear pair. Name me the other 2 angles that I would need in order to say that B and D are congruent. Alex?
D and C.
Not D and C,
And C. No.
not D and C,
B and C.
not B and C.
Oh my god.
A and D. A and D. So here we have, look, here we have these 2 angles here that are linear pair, okay? I'm trying to prove that D, this angle here, is congruent to this angle here. If I know that these 2 are a linear pair, A and D, okay? Now I'm using that transitive property, okay? If A plus D equals 180 degrees, and A plus D equals 180 degrees, right? then D and B have to be the same measurement. Right? These two have to be equal. If A plus B, if A is 120 and B is 60, this is still 120. So D still has to be 60. So now you just proved that B and D are the same measurements, right? They're the same measurements, and if they're the same measurements, you just proved that they are vertical angles, because vertical angles are two angles that share the same vertex, have no common sides, and are equal to each other in measurements. Okay? Equal to each other in measurements. All right, so for homework, I want you to try the rest of this all the way through 14. There's a 14 on the back. I know you can't do a formal proof yet, but just write down what's occurring, what has to happen, okay? Write it down in words. Write it down in words, see what takes place, okay, on those proofs. So go through 14 on the back, all these problems. A lot of them are easy. It's just identifying the vertical, the alternate interior, the alternate exterior, the same side interior again. Okay, you're just doing that. So it's just a visual inspection, and then some of it's actually doing you some proofs.
Can you show us?
Tomorrow in class, we have half day, and what I'm going to do is I'm going to have you write a proof in class tomorrow. It'll be fun. Go ahead and turn that off. Yes?
Can I